Hello and good afternoon, CSI135, Section 400, Fall 2013, Introduction to Linux students. This is going to be the solution set for lab number 4. As you can see in my bottom window is where I've got the questions that were required for this lab. In the upper window here, I'm going to go ahead and we're going to solve the lab, and I'm going to show you the solutions for the questions that are below. So without further ado, question number 1 says, for the following directories listed below, please provide the numeric representation of their permission settings. So I'm going to go ahead and cd into /temp/permissions. I'm going to type L, which is an alias out to ls-lai. All right, so here are the permissions as they've been listed. Whoops, just want this part here. So remember, the first bit dictates whether it's a directory or a regular file or a link. It tells you the type of file. So the next 3 permission bits are for the owner. The second 3 permission bits are for the group. And the last 3 permission bits are for everyone else. So if you're not the owner, which is TPB, and you're not in the group, faculty, then these last 3 permission settings apply to you. Remember that the R has a value of 4, the W a value of 2, and the X a value of 1. So the maximum permission setting for any given permission will be a 7, and then it'll be decremented from there depending on which permissions are on or off. So this first file here is 703. Directory number 2, the permissions would be 3, 4, whoops, sorry about that, 3, 4, 3. Directory number 3, the permissions would be 7, 4, 1. Directory number 4, the permissions would be 0, 1, 7. Directory number 5, your permissions are 0, 0, 1. Directory number 6, the permission settings would be 3, 1, 2. Whoops. For directory number 7, your permissions are 7, 7, 1. For directory number 8, it's 1, 1, 0. And for directory number 9, it's 0, 7, 5. Okay, whoops, forgot one there, directory number 10. Permissions on directory number 10 would be 5, 7, 0. All right, number 2 below asks, for each of the 10 directories you created in step number 1, you'll need to provide a command for each directory. In other words, you will have 10 commands when you're done that would have created the directories with the permissions you calculated in step number 1. The command each time needs to assume that the /temp/permissions directory never exists. So you will need to account for the creation of that directory at the same time and in the same single command. And what this is trying to get you to do is to combine the -m for the mode and -p for the parent directory creation of the makedir command. So we're going to go ahead and I'll do makedir /temp/permissions, and I'll go ahead and say we'll do permissions_2/dir1. Now, this command, while it will create the directory, will not create it with the permissions that we've got above. So, we want to use the -m for the mode, and directory number 1 had permissions of 703. So it would be 703. And the permissions_2 directory doesn't exist, so we need to make sure that that parent directory, to directory 1, has permissions set to 703, or it's actually created. So I hit enter, and I could do the same thing for directory 2. And so the command for directory 2, taking a look at the permissions, which are 343, so it'd be 343, and then the command for directory number 3 would be, where's directory number 3 there? 741. 1, 2, 3, so 741, and so on and so forth. And if I type ls-lai and /temp/permissions_2, you can see that my directories are there and that they have the correct permissions. Okay, that was number 2. Number 3, whoops, says there's a file located in the following directory, /temp/24/the following/dexter/homeland. All right, the file name is -rf. It says your task is to provide a command that could be used to delete the file with the name -rf. So a very easy way to do this would be to cd into your home directory. You can simply touch --rf, and let's type ls and see if that worked. It certainly did. So there's the -rf file. So, and again, the touch command has created this file for us. The -- is critical because this is going to be how we get rid of that file. So typically when you type rm, if you type dash, anything that follows the dash will be interpreted as an option to the rm command. But that's not what we want, because rf is a recursive and force removal of whatever follows that argument. So if I were to say period, that would remove everything in my home directory and all of the subdirectories. So in order to do this, you would do --rf, because the -- indicates that what follows is an argument, not options. So in other words, no other options follow. I type ls and it's gone. So there's the -r, so we could get rid of that in the same way. And now the -r is gone. So before, where we had the -r and the -rf, we removed rf and had just -r, and now we're left with none of those files. So they've been successfully removed. Okay, so number 4, in the same directory as step number 3, provide a command that could be used to delete the file with the name asterisk. So remember that the asterisk has a special meaning on the command line, and it actually will list out everything, because remember, the asterisk will match 0 or more of any character. So if I touch, and I'll put it in single quotes, because remember that single quotes get rid of the special meaning of the asterisk or any special character on the command line. So now we have the asterisk there. So to remove it, I could do the same thing. And if I type ls, you can see the asterisk is gone. So the first one was to ensure that no options were interpreted. And this one with the single quotes is to ensure that the special meaning of that special character, the asterisk, is not interpreted. All right, whoops, number 5. In your home directory, create a directory with the name bin. So to get to my home directory, I type cd, right? I'm already there, but if I was in, let's say, /temp/permissions, and I wanted to get to my home directory, I could just type cd. So once I'm here, I can type make dir bin, and this is a common thing that system administrators will do, or just normal users will do, is they'll create a bin directory, which stands for binary, and in that directory, in their home directory, they'll place any of the shell scripts that they've written, any executables that they would like to run will be placed in the bin directory. Okay, it says change the directory permissions to 700, so chmod space 700 on bin. So if I do an ls-lai, let's scoot back up and see what the permissions on bin are. As you can see, 700. Okay. And then on to number 6. What is the value of your path variable? So you'll remember that you can echo out the value of variables if you precede the variable name with a $sign. So if I type echo space $path, this is the value of my path statement. And so the path statement provides a list of directories that when I go to issue a command, these are the directories in which my shell will search for that command. And it's interesting here, you'll see the : and that dot stands for the current working directory. So it means the same thing here. You'll notice that the separator for each of the directory paths is a colon, and then the period here just simply means when I'm running a command, look in that directory, in the current working directory, to see if it's there. All right, so that was number 6. Number 7 says, what is one reason, and the reason that we've discussed, that would result in the following error message. And that's if you try to make a directory, and we've seen this before. So if I try to type make dir temp aacc, and I come back with that error, no such file or directory, it's because the parent directories don't exist. And so to resolve this, we would use that -p, right? And that's, as an alternative, I would have to go into temp and do make dir, and we'll just call it AA, then cd into AA, cd into AA, make dir bb, cd into bb, make dir kk, right? So it's much easier to run the single command with the -p and it will create those parent directories for you. Okay, number 8. Using only the cat command, create a file in your home directory that lists out the first 10 American Idol winners. You can name the file anything you want. So, typically what you would do here is you would go out to Google, get a list of the top 10 or the first 10 American Idol winners, and then you would use the cat command, and you're going to redirect the output from the cat command to a file called idols. And so here's where you would type in, and this is where I'm not too sure. I believe it was a Kelly Clarkson, and then maybe Ruben Studdard, and then Fantasia, so forth and so on. And when you're done, you would do Control D, right? And now if I type ls on idols, you can see I have a file here named idols. And if I cat that file, I've got the individuals whose names I had typed out on the command line. So again, cat with a greater than sign, and then a file name. It's going to create that file. And we'll do idols 2. And then anything you type in is going to be redirected into that file. And then Control D stops cat from doing what it's doing. Okay, number 9. What will the following command do and why? And this was the one that we talked about in class, where if you set the no clobber, right? If you set no clobber, this will be required to override no clobber. So if I type set space -o, let's take a look. No clobber is off. And so you remember we said to turn it on, you would do set space -o and then no clobber. So now if I type set space -o, we can see no clobber is on. So what no clobber prevents, and let me list out, oops, I'll get back into my home directory here. So no clobber prevents the accidental overwriting of a file. So if I were to type cat/etc password and then redirect the output of that into new file, and you'll notice I chose new file because new file exists. Let's see what happens. We get an error. It says cannot overwrite existing file. And so that greater than pipe is there to override that option. So if I cat new file, there's the password file. So the greater than pipe overrides the protection that no clobber gives you. All right, what will the following command do and why? And this is kind of a tricky one. It's very similar to one in the book, but it's going to run the cat command, but the first thing it's going to do is it's going to create not a file. And the cat command is going to take its input from no input here, the file no input here. So whatever's inside no input here will be concatenated and then redirected into not a file. And so let's set this up to see what happens here. So I'm going to type in vi no input here, and I'll do 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So 1 through 9. And now I'm going to type, oops, so we'll type greater than, not a file, space, less than, no input, oops, input here, and then cat. When I hit enter, you can see, did I spell that wrong? Oh, no input there. Let me make sure I've got the file name correct. Oh, input, no input. So, I'm going to typo input. So misspelled input as input, no input here. There we go. So again, we get cannot overwrite existing file because no clobber is on. So let's turn no clobber off. Set space +O, no clobber. And let's run that command again. All right. So as you can see, this confirmed two things. One, that command is a valid command. And two, that the set +O will effectively turn no clobber off. So now I'm no longer protected from accidentally overwriting existing files. So let's cat not a file, and let's see what's in there. And sure enough, if I cat no input here, identical as you would expect. All right, that was number 10. Number 11. By default, what is the size of the file in bytes that is created when dev null is used as standard in? So, if I were to use, let's cat/dev null, and I'm going to use that as my standard input, and we're going to put it in a file called myDevNull. All right, so if I type ls-la on myDevNull, you can see that the size is 0. All right, so the file size will be 0. All right, number 12. For each of the following, indicate whether the path name is an absolute path name or a relative path name. So remember the difference. The absolute path name will always begin with the /. The only exception is when it begins with a tilde. And then the relative path name will always begin without the / or the tilde. So this is a relative path name, absolute path name, relative path name, relative path name, absolute path name, because again, the tilde represents the absolute path name to your home directory. We've got absolute path name, relative path name, absolute path name, and relative path name. All right, on to number 13. Provide a single command, that could be used to append the contents of the following regular files into a single file without using the greater than redirection symbol. So we have 4 files here: stuff, junk, older stuff, and my junk. And we want to combine these files together without using the greater than. So the way to accomplish this would be to simply cat the files, and we'll touch stuff, touch junk, touch older stuff, and touch my junk. Okay, so you could cat the files. Oops. After creating them, and then use a single redirect, and we'll call it new file 2. And that command would concatenate out all 4 files, redirecting the output to the new file called new file 2. All right, number 14. Provide the single command that could be used to move the following regular files into the directory /temp. So that would be move stuff, junk, older stuff, and my junk into /temp. Now I'm going to hit enter, and it's going to ask override, and I'll say yes, see if we can. Somebody else may have already created some of these files. So if we ls and temp, let's see what we've got in there. Yeah, so junk, my new stuff. So those files already existed, but irrespective of that fact, this would be your command, right? Because move can take multiple arguments as long as the final argument is a directory, especially when you're moving files. All right, number 15, there's a file located in the following directory. Let's go /temp, do Control-U. So I'm going to cd into /temp, /red, /yellow, /blue, /green. Let's see what we have in here. All right, so we have a file called not-purple. It says provide a command that will display everything in the file except the color purple. And so that would be simply grep --v, and then and then purple and not purple, right? So remembering that the -v option with the grep command, whatever follows it, say we want to match everything except what follows the -v argument. And the final argument is the file name itself. So that was your answer for number 15. Number 16, who is the AACC user? And it says provide the user ID that logs in from an IP address that ends with .221.239. So you'll remember the last command will show you a list of everyone who's logged on. If we type man last, you can see, because we're going to be looking for the IP address, the -I option is like -D in that it displays the IP number of the remote host, but it displays the IP number in numbers and dots notation. So let's see what that looks like. If I do last --I. And sure enough, this gives us the IP. So now we're one step closer. So at this point, we would want to grep, and I'm going to go ahead and grep for 239. Let's see what we get. So as you can see, 221.239, there's only one user, and that is CSI135-400. So that's your answer for number 16. Now, using the mail program, send your answers in. And again, I'm going to go ahead and assume that my lab number 4 answers, SWRS, and I would send those to TPB, and let's say that new file is actually that file. So this is another way to do it. Remember, you know how to get into the compose section of mail, right, or the compose phase of mail, where you can use the ~r in the file name, but you can also redirect the input to the command with the greater than. Oh, and I think I removed new file. That's because I'm not in my home directory. All right, so new file is here. So now we'll do this, and as you can see, the homework has been sent out. All right, this is the lab solution set for lab number 4, Fall 2013 CSI 135 Section 400 Intro to Linux Students. All right, I hope this was valuable to you, and I hope that you've been able to find the answers that you were looking for if you missed any on the quiz. And I will see you all Wednesday night. Don't remember, we have our midterm. Have a great week.